the important concept, and that is regarding lungs and pleura. This concept is a very must-know type of information, and you are expected if lung and its surrounding areas and the structures related to it. I have never seen any respiratory exam where lung is not there. No matter in term of MCQ, in term of OSPI, or in term of SAQ plus minus, but for MCQ, for OSPI, take my words, if you don't find lung, it's not an exam. So if you ignore it, then enjoy it. I don't want to say much more for that. So now, what you're looking at the moment is the trachea, who bifurcates, and then it's being segmentalized, is being divided and divided and divided, the pattern of branching. What you should be knowing out of it, where is the primary and where is the secondary and where is the the terminal bronchiole, and just this is an orientation. I don't see any conceptual requirement to be knowing it. And another more thing, we have certain small segments, bronchopulmonary segments in our lungs. You need not to go for their names. We need to know only what is the definition of a bronchopulmonary segment. And remember, you open 10 books, what do you want? You open 10 books, you'll find 10 different versions. Some book says right and left lung 10 and 10. Some book says 8 and 10. Some book says 9 and 10. It's better, what I learned so far, talk about 10 and 10. And it's not a very big issue that you talk of 9 and 10 or 10 and 10 and this and that. So don't kill yourself for these minute small things. That's not really relevant for you at the moment. People know all that, they waste their time in learning these things, but they don't know what is the definition of a bronchopulmonary segment. That's more important than remembering the colors, this is the apical basal and this and that. And even I don't bother to look at that. So you'll not find any of those pictures in our today's talk. First, let's start from the beginning. The concept, this concept is not new for you. You had gone through from this concept from the peritoneum, then with the pericardium, now starting with the pleura. So we start with a balloon with two colors, and then it's not a new story. Your fist is going towards that, you are pushing in that, and your hand is going invaginating inside, but actually it's not going in the cavity. So that is my beginning of the lung and making of the pleuras. So then we demarcate the part which was red, that was given the name of the visceral layer, and the blue thing was the parietal layer. I hope everybody knows what is the meaning of visceral and what is parietal thing. Now this hand has been pushing up, this fist has been pushing inside, and now this space in between these two has been turned out to be the pleural cavity. Going further, we can see that now it is expanding and it is changing like this. So now this is the root of the lung, and this is the place from where structures enter or leave the lung. So there are different structures, neurovascular structures and lymphatics, they are going in, coming out. And this is how the concept of these layers, and this concept is uniform for you may go to abdomen, you may go to heart or any other place. I hope there is no issue in understanding whatsoever you have seen so far. Going further, we know that this is the visceral layer, parietal layer, and there is the pleural cavity. Pleural cavity is a very thin space, very small space, potential space, and it contains minimal amount of fluid because our lungs need to expand throughout If we stop breathing, we cannot survive. So with each breath, we have to move, and then for that we need some lubricating media where it can be facilitated. Going further, we call it hilum of the lung, and the place is called root of the lung, and this is the root of the lung. So now, what is this? The skin, the thoracic wall, and the lung rest over the diaphragm. Okay? Going further, if you look at a lung, it's not a flat structure, it's something like a pyramid. It has an apex, a base, and then there are different surfaces. Now, these surfaces, they are named according to the structure where it is facing. If it is facing the ribs, we call it costal surface. If it is facing the diaphragm, we call it diaphragmatic surface. If it's facing the vertebral gutter, then we call it posterior surface. So this is how we go for that. There are not so many. Let's level it. There are three borders. We have anterior border, posterior border, and inferior border. And we have surfaces also. Costal, mediastinal, and diaphragmatic. The apex part, the pleura who covers it, we call it apical pleura. The pleura who covers this mediastinal surface, we call it mediastinal pleura. And the pleura who covers the costal surface, we call it costal pleura. Right? So it's the same thing, but according to the location, we name it accordingly. Going further,
I'm sorry, but I can't see anything.
you can't see me, I'm not transparent, I know. So I can stand here. Now you can see it. But if you talk, I'll come and stand here again. That's the best way to stop you from talking. Now there you can see, this is the diaphragmatic surface, and this surface, the blue one, is the costal surface. And then this green thing, which is looking medially, is the mediastinal surface. I don't see there is any problem in knowing this stuff. Or is there anybody have some issue with this? So this part, we call it apical, and then we had suprapleural membrane and all that, which we talked before. Going further, this is my anterior border, as I said before. There is the posterior border, and these two lower down are the inferior border. So any lung, right or left, this is common to both. So now, these lungs, they have something more. This is the hilum and the root. You can see the structures, neurovascular bundle plus the air tube, they are entering into the substance of the lung. So we call it hilum, and the structure who are entering the root. That is the apex. Now, can you see a line which is transecting this lung? So this line has a name that is known as a fissure. It divides broadly, and this is how it continues. It divides the lung. It goes obliquely. You agree with that?
Yes.
And it divides the lung into lobes. Lobes, then further lobules. But primarily we have lobes. So one is oblique, and the right lung has an extra, that is a transverse fissure. So right lung has two, and the left lung has one. Okay? Is this clear? So we call it horizontal fissure, and we call it oblique fissure. Remember, these fissures should not be the criteria. If you are asked, sometimes we ask in the exam, determine the side of the lung. Please remember these words. Determine the side of the lung. You have to say it's a right lung or a left lung. Please don't focus only on fissures. I have some lungs with me in our lab where the left lung has two fissures, 3 lobes. So don't be deceived by only fissures. There are so many points. so many variables which helps you to understand that stuff. So go with that. Don't only be deceived by two fissures. And this was, I think so,
We asked
this question,
not last year, but before
that.
How can we identify?
Hmm?
How can we identify?
When you come to the lab,
I will teach
you, if I'm taking that lab. Or any of my colleagues will obviously tell you. If not, you are coming to the evening labs, I'll tell you there. So now we had superior lobe, there I have the middle lobe and I have the inferior lobe. Clear so far? So left lung usually has only an oblique fissure and two lobes, right? But left lung has some other features which we are talking shortly. Now we are going for, remember, I talked yesterday, our socks should be bigger than our foot. Then only we can wear them. So our lungs have to fit in the pleural cavity. And lungs need a space to expand. If there is no space to expand, then there will be no breathing. So for that reason, pleura has to be bigger than the lung itself. And now we'll go for how much is the difference anteriorly, how much is the difference laterally, and how much is the difference posteriorly. And once we know the limits of the lung and of the pleura, then only we can go for various procedures. It's not like you open up the thoracic cavity and you can see everything is flooded there and everything is being floating. Everything is being compartmentalized. Everything is organized in its place. And we need to be good with that, because once we are accessing, because there are situations where we need to aspirate pleural fluid, pleural effusion. So, and that is for diagnostic purposes. And this concept is entirely different from what we learned before regarding fluorosynthesis, like pneumothorax, hemothorax, and all that stuff. So that has a different axis. That's why I told you it's not end yet. We have some more axes and some more planes, because let's say someone have only 2 ml of fluid. Now if you approach from 5th or 6th intercostal space, if we want to take a little amount of fluid for our lab purposes, we don't need to put a drain. We don't need to insert a chest tube. We just need to insert a needle. We need to aspirate, take a sample of that fluid, and we need to send it to the lab so we can reach to the diagnosis. Understand? So we had, according to our objectives, we have to react differently. So how it is happening, if we are not aware of what are the limits of the lungs and what are the limits of the pleura, probably we cannot access to it. So let's see how we have things anteriorly. When we look at there are the lungs. They are looking at the right one and the left one. Left one shows a notch here. Why this notch? Because this makes heart to bit more exteriorized, and this is the place where heart is in direct contact with the anterior thoracic wall. And the process which is lower down, this one, we know it as the lingula. Make sense? So we have, this place is known as cardiac notch, and this is the lingula. Is that clear? Now, this is the extent of the lung anteriorly. Now, how we know what is the landmark? Up till which intercostal space we can see the lower limit of the lung. So, this pink color is just representing here that the visceral pleura is covering it. So we cannot see them separately. The gap is between parietal and the visceral layer. So now, and these are my, which lines? Mid-clavicular lines. Very good. Now, sixth intercostal space. This is resting position of the lung. It's not in full expanded lung. Normal resting position of the lung, sixth intercostal space is the lower limit. Beyond that, lung is not going. It stops here. Anteriorly, it can go up till sixth intercostal space. Right? Now let's look at where the pleura thing goes. Pleura is little more bigger than that. That's the parietal pleura. And so two spaces down, up till eighth intercostal space, we had the extent of the pleura. So during inspiration, a lung can expand anteriorly up till two intercostal space from its normal position. Is this point clear? So anteriorly, this is the extent of the lung where lung can go down. And once it exhales the air out, it can go to its resting position. Is this point clear? That's important. So mid-clavicular line, lung bases are at sixth intercostal space and parietal pleura up till eighth intercostal space. But be reminded, this is if you approach the lungs, if you approach the pleura anteriorly. Now what happens? If we approach laterally, the measurements are different. And this line is in the mid of the axilla, so what we should be calling it? Mid-axillary line. Right? And here, it's now eighth intercostal space. So lung is not a flat thing from its undersurface. It's sitting over the diaphragm, and these measurements are variable. So this is the extent that the base of the lung is reaching up to the eighth intercostal space, and the pleura add two more spaces. So 10th intercostal space is the extent of the parietal pleura. So laterally, these are the findings. I hope you understand. Now let's look. So posteriorly, when we look at the lung, Nasu, you have a problem? Do you need an early morning kick? So there are lines again on the back, and these lines have another name. We didn't talk about it yet. These are mid-scapular lines. So we learn now how many lines? No. Mid-clavicular, anterior axillary. Forget mammillary, that was just for some other talk. So what are relevant to us at the moment? Mid-clavicular, anterior axillary, mid-axillary, posterior axillary, and mid-scapular. Understand? So we have 3 and plus 2, 5 lines, which we should not ignore. Now posteriorly, the lower limit of the lung corresponds to 10th intercostal space, and the pleura extend 2 spaces below, that means up till the 12th intercostal space. Now, this whole exercise enables me to learn that if someone has small quantity of pleural fluid, and I like to go for pleural tap, look for the word. When you are asked to go for a pleural tap means you have to take pleural fluid. You are not dealing with hemothorax, pneumothorax, pyothorax or any or other type of chylothorax thing. You are going for a pleural tap, that is for diagnostic purposes. So usually you are going to the lowest limit of the pleural cavity from where you can extract out the smallest amount of fluid, and that is being usually taken by using a needle, and you can access it. Even if your needle goes to the liver, needle goes to lung, it's not causing a disaster. It might perforate it, and you can take it out and everything will go fine. There is no big deal if needle enters, but inserting a tube, that's a big issue. If that thing goes and that happens, then it will be a disaster. but for the needle. So for these procedures, and I'm sure when you'll be visiting